Welcome to Polypad. This is an online resource. It is housed in Amplify, which used to be known as Desmos Classroom. And Polypad itself houses a bunch of different manipulatives, but today I will be using the number bars because they are the same as Cuisenaire rods. Our goal today is to conceptually understand that adding and subtracting fractions involves breaking down wholes into equal parts and combining or removing those parts based on a common unit. When we look at adding or subtracting fractions, we are looking for them to be the same size parts of a whole. So if we were to look at adding 1/3 and 1/3. So if we were to add these, we would be able to without any extra work, because if we compare our denominators, they are the same size. They are breaking up our whole into the same size pieces. So we are able to say that this is a total of 2/3. But when our fractions are not in the same size pieces, it gets a little tricky. So let's look at 1/3 and 1/6. We can see that our whole is not sectioned into the same size pieces. On the left side with our 1/3, our whole is sectioned into 3 pieces, but on the right side, our whole is being sectioned into 6 pieces. And those are not going to create pieces of the same size. So we want to compare the two ways that we are breaking down our whole. And we want to create a way that they are the same size. So my 3 is smaller than my 6, so I'm going to duplicate this. And we can see that just by looking at it duplicated one time, we have the same size. So this is the size that we're going to use for our pieces. So this is our new denominator. This stays 1/6 because we did not change anything about it. But it's going to change with the 1/3 because now we have 2 of those. So we can see that for each denominator of 3, we have a 1 cube up top. So this is representing now, instead of 1/3, it is representing 2/6. And as a reminder, this is 1/6. So when we go to add these, we said our common size for our denominator was a 6. And then we have a total of 3 ones on top. So we can see that this is a total of 3/6. In this problem, we only had to change one of our denominators, but that doesn't always work out. Sometimes we might end up having to change both. So now let's look at adding 1/2 and 1/3. So we have one part of our whole that is 2. Then we have one section of a whole that's broken into 3 pieces. So when we compare our whole being broken into 2 parts and 3 parts, those parts are not the same size. So we cannot add them as they are. We have to take our denominators, or how many pieces our whole is being broke down into, and try to make them the same size. So I'll duplicate my 2, but now that's bigger, so I'll duplicate my 3. And I'm just going until they're the same size. So we can see that with 3 fractions that are set, 3 pieces that are 2, and 2 pieces that are 3, it gives us that same size. So I will have 2 iterations of my 1/3 and 3 iterations of my 1/2. So for each 2, it gets 1. It's the same for our 3s. So the fractions that we now have in front of us, we have a total of 3 1 blocks, and then the pieces that we're breaking our whole into is a total of 6, because we're getting that common denominator. So when we go to look at our final sum, we know that our denominator is going to have a 6. Then we have a total of 5 1s in our numerator up top. So when you add together 1/2 and 1/3, you get 5/6. This process is very similar for subtraction. You always want to find that common denominator, or that break your fraction into the same size pieces. So let's look at subtracting 2/3 and we will subtract 1/5. So we want to take away 1/5 from our 2/3. But we can see that our 2/3, our fraction that is broken up into 3 pieces, those pieces are bigger, or there's less pieces of our whole when we look at the 3 compared to the 5. So now this is where we duplicate until we have the same size. So this time it results in us needing 5 3s and 3 5s. Let's zoom out just a little bit more. There we go. So for each 3 rod, I needed 2 to reiterate my 2/3. Then for each 5, I need a 1. If we were to look at and merge our denominators here, we can see that we have 15 and 15. And it will show us that we also have a total of 10 on top of the left and 3 on the right. So we are doing 10 fifteenths take away 3 fifteenths. So we have that denominator of 15. That is how many pieces we're breaking our whole into. And if we have 10 take away 3 pieces, that's going to give us a total of 7 pieces left on the top. So if I do 2/3 minus 1/5, I'm left with 7 fifteenths.